Aggregating data with group functions. In this nugget, we're going to pick up where we left off in the previous nugget in which I described single row functions. And here we're going to look at the multi-row analog, the aggregate function. I'm going to show you the major grouping related functions that Oracle offers us, and I'm also going to describe and show how our aggregate SQL functions work hand in glove with two very important clauses in SQL, group by and having. As we're going to learn, we use group by to aggregate data and bunch it together based on criteria, and having is akin to the where clause, but we apply filtering not to individual rows in the table but to entire groups. Let's get to work. All of the functions we've dealt with thus far in the course are what are known as scalar functions, inasmuch as they return not a set as their return value but a single result or a single value. As we've already talked about in the previous nugget, we did single row functions that operate on one row at a time in atomic units. Here we're looking at group functions that operate on multiple rows. Some of the more common group-related functions in Oracle are things like AVG for average, min, max, count, and sum. These are probably going to be your go-to group functions. All of them has a really useful, function. Let's say you have a database table that stores students and their grades. Of course, things like numeric grades are useful for number crunching and analysis in an educational context. We can easily aggregate those grades and come up with an average grade. We can see who is the least performing student in the class by running the min function. The max function gives us, of course, the other extreme. There are many statistics related group functions that enable you to do variance and standard deviation and this kind of stuff. Some wouldn't work so well for student grades, but certainly could work well for budget data, for prices, for salaries, etc. And count is very useful for giving us row counts. If you want to see, for instance, how many employees we have in our employees table, how many students we have in a students table, how many products we have in a products table, etc. It's a really useful function to do that, and we can throw in the distinct qualifier, which we'll show you in the upcoming demo, that can avoid duplicates and give you a true count of unique entities within a particular table column. You should also be aware preliminarily that group functions ignore null values by default, so that can give you some unexpected results as you're working with these group functions. So we should remediate that issue wherever possible by substituting nulls for some at least placeholder value by invoking the NVL function. You'll remember the NVL function from the previous nugget that operates on null fields and can replace them with some placeholder. Remember, when we run selects against data, we're not destroying or perturbing any of the data within the table. We're going to work with update and insert later in the course. And then, of course, I mentioned the distinct. All right, so far so good with aggregate functions. I think you understand their importance in a business context. Now, what about grouping? Let's take a look at this as a simple example to show you the benefit of using aggregate functions with grouping in Oracle. Over on the left here, I've given you two columns from a sample table. The first column, salesperson ID. Second column, sales. Now, let's take a look at the values as we go through here. This is obviously some sort of sales-related table in which the salesperson ID is not a primary key. We know that right off the bat because the primary key constraint ensures that every row in that column is unique. So there's probably a sales transaction ID that serves as the primary key in this table. I'm just giving you that as a little bit of relational database background and to make this example a little bit more realistic. Anyway, you'll notice that salesperson ID 400 shows up in this table a number of times because presumably this salesperson has made at least 5 sales. Salesperson ID 500 shows up again multiple times, as is 600. Now that's all well and good just looking at it, but grouping can really help us because instead of having to just take this raw data and maybe compute in your head, well, it looks like salesperson 400 did 20,000 or so, it looks like salesperson 5,000 did, again, 18, 17,000. We can use aggregate functions with the group by SQL clause to get really nice summary information. After all, the word aggregate means a sum or a combination of individual constituent components. So after applying, it looks like in this example, the average aggregate function, along with SQL that we haven't actually showed you yet, the group by clause, The end result is we're able to see each unique entity within the salesperson ID column in this sales table, and then based on our aggregate function, whatever it is, it could be sum, it could be min, it could be max, a lot of interesting stuff there, we see that value. So this is a really nice, powerful way to perform basic roll-ups of data in your table. The syntax for using grouping is pretty straightforward. We're just going to bolt on an additional clause to what we've got going on in our selects. We already know that selects start with select and then the column list. In this case, though, this is a big distinction actually when we use grouping. We're going to talk more about this in just a moment. You can only include one of two types of columns or expressions in your select list. It's assumed we're going to use at least one aggregate function. It operates on a column in that table. Any other column that we reference in our select statement needs to appear in the group by clause. Basically, we're avoiding ambiguity. If you throw in a bunch of columns in your select statement and then try to aggregate values on a column using a grouping function and then roll up based on another column, Oracle is going to get all kinds of confused and you're going to get the ORA 979 error that says you don't have a group by expression. Start with select from destination table. If we want to do row filtering at that point, that's where we would introduce a where clause as previously discussed. After a where, you can then, if you want to, do a group. Now again, group by, and then we provide some expression. That expression is going to reference a column that has to appear in the select column list. So we might have select salary, comma, sum of salary, and then in our group by clause, we would need to include that column, salary. So this tells Oracle, I want you to roll up or aggregate data in this select statement. It's already been retrieved and already been initially filtered based on that column, salary. Note also that no column aliases are allowed with the group by clause. And note also, order by comes at the very end. So select from where group order is the orthodox way to roll out these SQL keywords. Of course, where is optional. You don't have to have a where expression when you initially pull back your rows. And order by is certainly optional, and technically group by is optional as well. The only required keywords in a select statement, as you already know, are select and from. To step up the complexity a little bit, it's certainly possible to do multi-column grouping. Let's take a look at our original table up front. We have a division ID column that, again, is probably a foreign key based on a divisions table elsewhere in our schema, because it looks like we have the same division represented multiple times. You see what I'm saying? At least in three cases, 400, 500, and 600. Those divisions include one or more departments within our organization. And then each of those departments has some base salary. I'm not sure exactly what we're doing with salary here. It doesn't really matter. Bottom line is, where you have repeating values in more than one column, you can in fact do multi-level groups. And you specify that in SQL by specifying group by, and then in your argument list, simply provide order in which you want your groups to happen. So in this case, if I do group by division ID, comma, space, department ID, and we're first going to group by division, and then secondarily group by department. And then with that grouping, we're going to perform some kind of aggregate function. As I mentioned, grouping sounds fine on paper, seems easy enough. There are a couple gotchas. I'm going to explain them here, but they'll make more sense once I show you in the Oracle environment. First of those gotchas is, as I've already told you, in your select statement, the column or expression besides the aggregate function has to appear in the group by clause. So if you wanted to do a roll-up of salary, you would have the salary column, maybe in, I don't know, average work, and you might have a department column. When you do group by, unless you group by that other column, Oracle is going to generate the previously mentioned ORA error. You see, it needs to be really clear to Oracle how it's performing the grouping. I mean, doing the aggregate function, you could run average salary from employees all day long. But in terms of grouping on a criteria, Oracle needs to know what that criteria is. And if we were to throw in extra columns here, like first name, last name, and group by department, Oracle is going to say, all right, I understand how to group by department, but I don't understand how this fits in with first name and last name. You see what I mean? I know how to perform an average on all salaries within each department, but I'm not sure what's going on here as far as grouping or aggregating first name or last name columns. Kind of difficult to understand theoretically. I'll show it to you in practice though in just a little bit. The second thing, and this leads to the second part of this nugget, is that we use the where clause to filter rows initially in our select statement. The where clause cannot be used to restrict groups. Some folks who are fairly new to SQL will write a select statement, bypass the where clause, and immediately try to use group as a way to filter rows. It's not going to work like that. The having clause is what we use with the group by clause to perform group level filtering. So think about it in your mind like this. Where is used to perform an initial row filter. Group by is used to perform a group level filter. Therefore, to restrict group results, this is the order of operation. First, we have our initial select, optionally a where clause that kind of funnels down the number of rows that are to be grouped. In the second stage, the rows are going to be grouped according to whatever your group by expression states. Third, the aggregate function is applied to those remaining rows, average salary, min salary, max grade, and so forth. And then finally and only after this second level of filtration is performed on those rows, you have your optional having restriction, which simply functions as an expression just like the where clause does. It's very similar in that regard. It's actually identical. Without further ado, let's get out into the Oracle environment and we'll start working with some of these concepts in living color. In this demonstration, we'll look at aggregate functions and the group by SQL clause, which, as you know by now, go together like peanut butter and jelly. Let's open our work file for this exercise. I'm calling it Reporting Aggregated Data Using Group Functions. And the first thing I'm doing here is running a select splat from employees. Not very useful because there are so many darn columns in the table, but in particular we're going to start with just the salary column, which you see over here, and we're going to create some pseudo columns from the employees table that involve not yet grouping, but just the aggregate function itself. So you see, if we want an average of all salaries in our entire employees table, we can invoke the function name and then pass in the column as its argument. And we can use rounding, and we could use toChar and apply string formatting if we want this output to show up like currency, but I think you get the general idea. That's a high degree of precision that Oracle gives back to us by default, doesn't it? Min and max allow you to look at extremes in your data set. Select min salary is 2100. Looks like our max salary, by contrast, is 24,000. That's quite a range of salaries, wouldn't you agree? If you're planning budgets and you need a sum of all yearly salaries, we can simply invoke the sum aggregate function. Most business people and IT professionals with whom I've worked have experience with these basic aggregate functions. You've probably, like I have, used them a lot in desktop applications like Microsoft Excel. They tend to come in handy there. Count is your go-to aggregate function for row counts. So if we run a select count splat from employees, it's going to give us a run or a result that tells us how many rows are in that table. 107 for the Oracle HR.employees table. We can also combine these. We can nest functions one inside the other, or we could just, using a comma-separated pseudo-column list in our select statement, be able to analyze all of those preceding values in one go. So you see, in this line 15, we're not actually returning the raw value of any column, but instead invoking three pseudo columns. We're getting the average, the min, and the max. Now we could just cut the statement off right there by adding a semicolon, selecting those lines, and running that selection. There's our average, min, and max in one go. Or we can invoke the where clause, which we've already learned about. This is our row filter, and this is saying show me the average salary, min salary, and max salary for everybody whose job title includes clerk. Now, if you're not watching these nugget movies in order, shame on you. Just kidding. But this is a good example of where doing so can be helpful, because at this point, if you have been watching the nuggets sequentially, you already know how to use the where clause as well as how to use the like operator and these wildcard characters like the %. So let's run this batch here, and it gives us again just the data we need. So it looks like within the clerk job role. The min salary is $2,100, which I remember was the min for the entire table. So evidently a clerk is the possessor of the dubious distinction of having the lowest salary. Their max salary isn't that high either, unfortunately. Boy, it's depressing. Now you can also run counts on specific columns. If you want just a raw row count from an entire table, then you would use select count star. If you want to look for values within a particular column, pass in the column name as the argument. So what we're seeing here is we want to answer how many department IDs exist in our employee table. So at first blush you might think, as on row 19 shows, we would pass in department ID. Well, let's run this query and we get back 106. Now that doesn't tell us exactly if we have duplicates. If we're coming in as an Oracle consultant, unless we've looked at our ERD or entity relationship diagram, we may not know that you and I know that department ID is the foreign key side of a relationship. So department ID actually is duplicated quite a bit in the employees table. I can prove that by running select department ID from employees, and we'll do an order by department ID ascending. And immediately you see duplication here. And that makes sense because you, in general, have more than one employee in a specific department in the organization. So we may get some, in fact, we're definitely getting anomalous data here by just running a select count. This tells us how many instances of department ID they are, but irrespective of duplication. Distinct, as I've mentioned in the whiteboard portion of this nugget, allows us to look at unique values. So this is going to give us a true picture of how many unique department IDs exist in the employees table. And how you use that is as an argument. So count and then open parentheses, distinct, and then the column name. Let's run this. Wow, that's quite a difference, isn't it? In fact, let's put them side by side. We'll run select count department ID as raw count, and then we'll do count distinct as unique count from employees. Right, so that's quite a difference indeed. Only 11 unique department IDs. Of course, if we want to see the names of those distinct department IDs, we can use the distinct keyword as part of our select clause. So we could say select distinct department ID from employees, and now they come back. Now it looks like there is a null there. It's an interesting design thing, and we'd probably want to put an order by to make this a little bit easier to comprehend. Let's run this query again, and there you go. Looks like we have 10, 20, 30, 40, 50, all the way through 110. Next on line 30, let's look at another wrinkle here. The first thing we're doing is selecting the average of the commission percent column in the employees table, and then looks like we have some nested functions. Now what's happening here? In our second pseudo column, it looks like we're invoking the NVL function, which you'll remember is a substitution function where it can look for null values in that column and replace them with a valid value. I mean, just by point of reference, let me do a select commission PCT from employees, and I'll order by commission PCT. We've used this before, so you're familiar with this column. It ranges from 0.1% all the way up to 0.4, and then there's a whole lot of employees, maybe they just are not salespeople, who don't have a commission associated with them. Now if we run a select count, we come back with only 35 rows. The issue here is nullability. The count is going to grab only non-null values by default. Same with our average function. So if we want to include those null values in our computation, we would have to do something like, as I'm showing, I'm kind of bringing us back around to this query clause that begins on line 35 by invoking NVL. So what we're doing here is taking the commission and percent column, replacing all null values with 0, which certainly fall into an average computation. Null doesn't. Remember, null is an unknown value and is never evaluated as a number or even as character data. So that will get rid of the nulls, and then we pass that result into the outer average function. See? So we're getting kind of jiggy with it, as I like to say. And this gives us the original average that doesn't include nulls, and then the one that does. Now you notice the number is quite different. The original average is 0.22, which makes sense if you want to look at only those employees who have a non-null commission percentage. The average that includes the nulls is going to obviously dilute that value and take it down a great deal, down to 0.07%. So much for aggregate functions. Now let's tie aggregate functions into the group by clause. On line 39, we see our first example of using group by. Remember, group enables us to aggregate or bunch select results together based on a column. Remember that the only elements that can exist in your select statement are aggregate functions and columns that will appear in the group by clause. So your group reports are on their face going to be really bare bones. The reason for this, remember, is that we need to be as explicit as possible so Oracle knows what it's grouping and then what it's operating on with respect to those groups. So it looks like in this case we want to see the question that's being answered here is what is the average salary by department in our employees table. So therefore we're going to grab the column on which we want to group. We want to see by department ID, and then the aggregate function that we're applying in that group schema is round, is average, the inner function. And again, we have a nested function situation where we're first finding the average of the salary column, and then we're passing that scalar result into the outer function that's going to round the result to 2 decimal places, just to avoid this kind of stuff that we're seeing down here. After all, we're not scientists, and we're aliasing that result as AVG salary. Now, how do we do the grouping? It's not just a case of choosing an appropriate column and one or more aggregate functions. We have to specify after the from and then optionally where. The group by statement, it's very simple. Group by and then you pass in that column. Now, for easier legibility, I'm also going to throw in order by that value so we can see department IDs in ascending order. We select this, and there you have it. Nice report. It shows us average salary grouped by unique department. And as we've looked at before with select distinct and select count distinct, we have department IDs that range from 10 to 110. Now, here's a thought question for you. You may be thinking, well, Tim, this is pretty cool stuff. This is really useful for my business, but my boss is not going to appreciate seeing this as a report, department ID 10, 20, 30. Chances are only the DBAs and DB developers know that department 10, for instance, is the clerk department and department 70 is the IT department. How can we format this such that we substitute the department names instead of the IDs? And if you're thinking that question, good for you. You're really thinking like a database administrator and even, dare I say it, a database developer. The answer to that question is we use table joins to do that. It really leverages the power of related tables and the relational database schema. Now, we haven't gotten to joins yet. We're going to deep dive into those a little bit later in the course. So bookmark that question and we'll come back to it a bit later. You'll remember in the whiteboard portion of this nugget, I mentioned that it's eminently possible to do multi-level groups. The only gotchas there are, number one, you have to think what is going to be my first level group and second level group, and you have to specify those as an ordered, comma-separated list here in your group by clause. And the other thing you need to remember is that those group by columns have to appear in the select list up above. So in this column, we're grabbing department ID and aliasing it, job ID and aliasing it, and then the aggregate function that we're performing here, again, it's nested, is we're going to compute the average salary and we're going to truncate that. You remember that trunc is the aggregate function that just doesn't do rounding. It chops off everything after the decimal point. So we're just going to have an integer as our salary average pseudo column. And again, I'm grouping by first department ID and then job ID. Let's throw in one more column here. Order by department ID, job ID. There we go. So you notice that we're first grouping by department ID in an ascending fashion, and then within those groups, we're using job ID as a second level group option. Alrighty then, let's transition over to my second query builder. I wanted to demonstrate that rule that when we use the group by clause, we have to group by a column that appears in the select list. To prove that, let's go to line 7 here, where I want to see average salary by department ID from the employees table. Now to do that, we know, because I've shown you this exact example, we're going to select on that column to be grouped. Obviously, we have to see that column in the results. That's going to defeat the purpose if we don't. Our aggregate function in this example is average, but here I want to see some additional information like last name. You might think, well, okay, that's an innocent question to ask of Oracle, but it will fail every time. And as you see down below, Oracle tells us that this is not a group by expression. We get an ORA 979 error. So to correct that, we're going to have to edit the select statement to ensure that the only elements that exist in there are group by columns and aggregate functions. That's just the way this works. The other thing I wanted to show you here is the snippets feature of Oracle SQL Developer. It's kind of cool. It can help you a little bit with syntax. Certainly it can help me, and it does help me remember what's available with respect to built-in functions in Oracle. Open the View menu, come down almost to the bottom and select Snippets, and it opens as a panel here. And you notice that first we have a drop-down. These snippets can be time-saving elements for you, as I said. If we open the drop-down here, it shows us the functions grouped by category. It defaults to aggregate functions, which is useful for our purposes, and shows us count, max, medium, min. And as I said, it can be helpful to remember what these functions are, that they exist, and what the syntax is. So count, for instance, you notice it mentions all or distinct as optional parameters. Some of them just have EXPR to denote an expression. If you hover your mouse over a snippet, you get some tooltip help. It returns the sum of values of expression, etc. These are pretty straightforward, actually. Once you get into the more complex functions like analytic functions, date-time functions that have a little bit more robust syntax, it can be helpful to have Oracle include in the snippet code some of the parameters. Now, how do these work? You simply drag them out as you're doing your query. So for our purposes, for aggregate functions, we could be starting a query like select, and then we want a row count. We can just drag out that value from employees. Just a way to help you a little bit with the syntax, as I said. So that's how that works. You just specify your category and go from there. There's also the ability to add your own user-defined snippet. To do that, you click the plus button, as I just did. Assign your new snippet to a category, give it a name, provide tooltip help, and then the code that you want to include, so you can actually customize built-in snippets or build your own from scratch. Pretty neat there. Now, let's finish this demonstration by coming back to my original query builder. The only thing we have yet to discuss is the having clause. So let's look at 51 here. That's going to kind of roll up what we've learned thus far. We know about using the group by clause. We know about aggregate functions. So on its face, this query looks pretty straightforward, doesn't it? Again, department ID, average of salary, group by department ID. You'll recall that where is our row level filter, and we specify where before group by, before our group. In this example, we're not going to do that. The having clause is what we use to provide filtering on the groups. So in this case, we want to see only those departments that have an average salary of greater than $9,000, and we're going to order that by department ID. So in those results, we're seeing a subset of the initial group. I mean, up to this point, we're going to see every department ID in the table and an average of its salary. Having, just to repeat, please forgive the redundancy if you feel I am being redundant, but when we start getting into trickier concepts here, I think repetition does make a nice impact. The having clause is going to filter those groups based on an expression. Final example we have here is this monster beginning on line 58. This example includes both the having and the where being used together. So it serves as a nice capstone for this demonstration, actually. Now then, our select list, we're taking the job ID column and the sum of the salary column from the employees table. Here we are going to perform an initial row level filter using where. In other words, show me the sum of all salaries per job ID, but only where the job IDs include the word clerk. So that is going to initially round down what's being grouped. We'll group by job ID, and then once we reach that point, we're going to filter down our resulting groups to see only those job ID groups that are left where the sum of the salary is greater than $11,000, and then we're ordering by that value. So net result, we wind up with 3 job IDs that meet both those criteria. The job ID includes clerk, and the salary sum is greater than $11,000. Aggregating data with group functions review. The main takeaway message I hope you'll pull from this nugget is the hand-in-glove relationship between aggregate or grouping related functions and then using the group by function itself to filter at the group level. We also know how to use now the having clause, which again functions hand in glove with the group by clause to restrict data rows. At this point, you not only understand the basic mechanics of select, but you also have some extremely powerful, probably the most commonly used clauses in the entire SQL language, namely order by, where, group by, and having. If you understand what we've been doing so far and are fairly conversant with these keywords and clauses, then you are well over halfway to mastering the concepts of the SQL Fundamentals course. This really performs the vast majority of our select-related functions. I hope that this has been informative for you, and I'd like to thank you for viewing.